Today we are going to do the first lesson of the part 2 book in grade 9 science. 10th lesson, electrolysis. There are 10 lessons and now we are going to do the 10th lesson, electrolysis. This lesson is very important because it is coming for O levels. Let's get started. First subtopic, electrolysis. There was a news item of a woman who has been cooking food, keeping an aluminium pan on an electric. Like a hot plate was struck with an electric shock when she was pouring coconut milk into the curry. She had got a shock even though she was not touching the pan. How could this have happened? The leaking electric current should have passed through coconut milk and entered the woman's body. Your elders must have told you that connecting electric plugs with the wet hands is dangerous. The reason for the electric leaks stated above should be the conclusion of electricity through a liquid medium. So now we are going to do activity 10.1 to find out whether electricity is conducted through any substance in liquid state. To do activity 10.1, you will need a beaker, 2 carbon rods, ammeter, 2 dry cells, connecting wires. You need several liquids or solutions as kerosene, salt solution, acidified water, copper sulfate solution, and distilled water. So you need to connect the ammeter and 2 dry cells to carbon rods as in this figure and dip these 2 carbon rods into the beaker and pour the liquids or solution given above one by one. So you need to observe whether there is a deflection in the ammeter. When you tabulate your observations, you can see as this. Liquids or solution causing a deflection in ammeter, and in that side you can see liquids and solution not causing a deflection in the ammeter. Salt solution, copper sulfate solution, acidified water. For these liquids or solution, you can see a deflection. But kerosene and distilled water, you cannot see deflection in the ammeter. So the conclusion of this activity is detector of the ammeter reflects when a current passes through it. Therefore, a current has passed through the solutions resulting the deflection in the ammeter. They are salt solution, copper sulfate solution, and acidified water. The solution of salt, copper sulfate, and acidified water all contains mobile ions. So these liquids or solutions which conduct electricity are called electrolytes. Liquids or solution which conduct electricity is called electrolytes. Since kerosene and distilled water do not conduct electricity, they do not bring about a deflection in ammeter. Such liquids in solution do not conduct electricity as they do not contain mobile ions. So these liquids or solution which do not conduct electricity are referred to as non-electrolytes. Liquids or solution which conduct electricity called electrolytes, and liquids or solution which do not conduct electricity called non-electrolytes. Compounds such as sodium chloride and copper sulfate are known as ionic compounds. They exist in a solid state. They are made up oppositely charged ions from the relevant atoms. You will be able to learn about them in grade 10. Although the ions in solid ionic compound, they cannot move freely. You have learned the structure of a solid, so they can't move freely. Those compounds do not conduct electricity in a solid state. But if those ionic compound is dissolved in water to give an aqueous solution, the ions in the solid state becomes mobile. So this aqueous solution of ionic compounds are good conductors of electricity. When an ionic solid is heated and brought the liquid state, it's called fused substance. Only heated, not adding water, it's called fused. Ions in fused liquid also can move because when it's fused, it's not solid. Accordingly, ionic compounds conduct electricity in fused state. Now we are going to do the second subtopic, changes caused in a solution by an electric current. When electricity is conducted through an electrolyte, the conducts through which the electric current enters the electrolyte and exits are called electrodes. You should remember it. In this activity 10.1, electric current enters the solution by one carbon electrode and exits from the solution through other carbon electrode. Then it's exit from this carbon electrode. In activity 10.2, you need a beaker, ammeter, connecting wires, copper sulfate solution, carbon electrode, 2 dry cells. Here this carbon electrode connects to the positive terminal of the dry cells. dry cell, and it's called positive electrode. And the negative terminal of the dry cell connect to this carbon electrode, and it's called negative electrode. And also it's called anode and cathode. The electrode connected to positive terminal of external apply of electricity is called positive electrode, as I told you. And also the electrode connect to the negative terminal external supply of electricity is called negative electrode. In this activity, you can see deposition of a reddish brown substances of the negative electrode. You can see reddish brown substances deposits in this negative electrode. And liberation of gas bubbles at the positive electrode. Liberation of gas bubbles. A gradual decrease in the blue color can also be observed in the solution. These are three observations that you can see from this activity. So you can see this beaker undergo a chemical change. So this chemical change is caused by electric current passed through the solution. So this reddish brown color substances deposit in this negative electrode is copper. And oxygen gas is liberated at the positive electrode. Copper sulfate undergoing the chemical change has turned into copper, a simpler substance. This, the chemical change effected by passing an electric current through the electrolyte is known as electrolysis. The substances that doesn't react chemically with electrolyte referred as inert electrodes. Carbon or graphite and platinum electrodes are such examples. Electrolysis of acidulated water. Activity 10.3, you need distilled water with a few drops of dilute sulfuric acid. 9-volt battery, 2 carbon rods, plastic container, connecting wires and 2 test tubes. And you need to make like this. And in this activity, you can observe that gas bubbles evolve at the electrodes and collecting in the test tubes. Volumes of the gas collected at negative electrode is approximately twice the volumes of the gas collected at the positive electrode. As you can see, it can be examined that hydrogen gas evolves at the negative electrode and oxygen. Hydrogen gas in negative electrode and oxygen in positive electrode. When you get the conclusion, gas evolved at the positive electrodes collected and tested with a glowing splint. So when you do the activity, we know that hydrogen collects in negative electrode and oxygen collect in positive electrode, but we have to test. So to test these gases, um, we can do two activities. To test oxygen gas, we need a glowing splint, and we need to put into it the splint rigidity. If the splint rigidity, this verifies it is oxygen gas evolved at the positive electrode. Next, we need to confirm this is as hydrogen gas. So we need lighted splint is put into it. The gas burns with the pop sound. If it is so, it verifies it is hydrogen gas evolved at the negative electrode. Application of electrolysis. Electrolysis is frequently used in various industries. Extraction of metals, examples are sodium, aluminium, industrial manufacture of caustic soda or sodium hydroxide, and also electroplating. I'm going to do the next subtopic electroplating with another video. And don't forget to subscribe for the more videos and also more lessons. And thank you for watching.